Today I'm going to show you how to work with this apparatus to find isentropic exponent of gas, any gas. For this experiment we are going to use air and argon. Let's see what are the main parts of this apparatus. The first and main part is this transparent cylinder. As you can see here, it comes with two valves which we can open and close to give access gas for the cylinder, inside cylinder, so we can control the amount of gas we have inside. If you focus inside the transparent cylinder, you can see we have two distinct sensors. One, it is going to be a temperature sensor inside this green rectangular shaped sensor, which consists of very fine nickel wires. If you try your best, you may be able to see those wires. Also, we have a pressure gauge or sensor inside this valve, which means we can read pressure and temperature inside this transparent cylinder for the gas we have. We also need to find the volume of the gas. This black area here is going to show us the volume. So depends on the position of this handle, this apparatus is going to show us the volume of the gas inside this tank, and it is already calibrated. So if we want to suck some gas inside, you need to increase this handle gradually to have some gas inside. And we have some gauges here. We can read what is the height starting from 0 centimeter till about 16 centimeter, which is the maximum. Okay, what else we have? We have 4 connections here. The first one is going to be power. Second one is temperature cable, volume cable, and pressure cable. So temperature is going to be connected using these cables to the interface. We have this interface, which is kind of connection between this apparatus and computer. So you need to be careful and follow the cable. For example, if you connected temperature to this cable, so you need to follow and connect to the, for example, A, B, C. So, and you need to know which cable A, B, C is connected to temperature, and also for the others. Then you need to connect this interface using this cable to computer USB port. This interface also comes with the power, so you need to also connect this USB to the electricity to start function. After connecting all the cables to interface and interface to computer USB, you need to click on the Pascal software, which we already provided in this computer. So double click it to turn on this Pascal software. As you can see, we have several different parts on the left side. The first one is hardware setup. You need to make sure the setup is ready. So automatically software is going to recognize the type of interface we have. For example, here it is Science Workshop 750 interface, which you can see here, it is already recognized. Now, because we connected 3 sensors to port A, B, C, I'm going to tell the software I have 3 sensors connected to ABC ports, DIN ports. So I'm going to click over this yellow circle for port A, and it is going to show me a list of possible sensors we have there. The type of sensors we have for this experiment is voltage sensor. So I'm going to select voltage sensor, and as you can see, it is shown for part A. For B, again it is voltage sensor. For port C, voltage sensor. So I identified 3 different voltage sensors for A and B and C. Later, I'm going to assign the type of those voltage sensors. To assign those voltage sensors, you need to go to calculator. I open calculator, and now it's time to assign those parameters. Click new, and as you can see, it is showing me what the area to input some formula. Behind or at the back side of this apparatus, there are some calibration formula. Please take a picture of those calibration formula and enter those formula here. The first one is temperature, T. I'm naming it T. It's going to be equal voltage of C port. So I'm going to click this insert data and select voltage C here and multiply it by 68.86 plus 239.1, and now it's time to specify unit. The unit is Kelvin. I type K and select from the selected presented units. The second one is going to be volume, which is going to be equal 2.26 E negative 5 times voltage of sensor B, which is for volume. We already connected to connection B, plus 8.56 E negative 5. Now it's time for unit. For volume, definitely it is going to be cubic meter. So now I found from the available volumes presented there. The last one is going to be pressure. P is going to be equal voltage sensor of A times 100. And the unit for this pressure is going to be kilopascal. We type it and select from the list of units. Because I want to find isentropic exponent, and as you can see in your prac handout, the isentropic exponent is going to be slope of the graph when you draw ln of pressure over ln of volume. So I want to define ln of pressure equal ln of pressure, which is going to be again kilopascal. The next one is going to be ln for volume, which should be equal ln of volume, and again unit for that is going to be cubic meter. Okay, now we are happy with this and we can start our experiment. Before starting experiment, you need to specify a few graphs. On the right side, we have graph icon. I'm going to double click 4 times. 1, 2, 3, 4. And for y and x axis, I can specify each of those parameters. For example, for the number 1, I'm going to specify pressure, and the x-axis is automatically going to be time. For the second one, I'm going to specify volume. Again, automatically time is selected. Third one is going to be temperature and time for x. Fourth one, I want to be ln of pressure and ln of volume. So I'm going to select ln of pressure, and for the time I want ln. Also, let's push the graph to find the slope of the line, which is going to be Isentropic exponent. So I'm going to select linear feet, and automatically software is going to generate and fit a straight line for my data, and the slope of that straight line is going to be my isentropic exponent. Okay, now it's time to start experiment. Let me explain what is the procedure of this experiment. You need to suck some air inside this transparent cylinder. So to import some air inside that cylinder, you are going to gradually raise this handle. Up to what stage? Up to height, which is you are going to select. For example, 14 centimeter is going to be enough. Now I increase up to 14 centimeter. I'm going to watch it vertically to make sure my recording, my experiment is accurate enough. So use your elbow like this to keep this level constant. Otherwise, your data is going to have unnecessary fluctuations. So inside this cylinder, I have air, and pressure is atmospheric pressure. So if it's gauge pressure, it is going to be 0. And now it's time to close the valve. Okay, I close the valve. I'm careful not to change the level at all to have better data. Let me bring my mouse here. Okay. So now air is trapped inside this cylinder. Because isentropic exponent is going to be calculated using adiabatic process, I need to have very fast process to be adiabatic, which Q or heat transfer should be 0. If the process is slow, temperature is going to be constant, and we called it isothermal process. But for this case, it should be adiabatic process. So I want to have very fast process to be adiabatic. So Q would be 0, and during that process, I'm going to activate software. There is a record button, red circular icon. I'm going to press like a half a second before pressing this handle, and recording is going to start. And after pressing this handle to the minimum position, which you are going to see, that minimum position is defined with this pin. This pin is going to stop this handle at this level. So whenever we reach that pin, I'm going to stop recording it. Again, I'm repeating, this process should be adiabatic. And our research shows for this apparatus, if you want to have real adiabatic process, your pressurizing process should be under 0.2 seconds. So it should be very fast, but not too hard to break the apparatus. Let's do it. I'm going to repeat, press record button and immediately start pressing. Okay, let's see what type of data we found here. The first one on the top, I selected to be pressure. During this adiabatic process, we have pressure increasing all of a sudden, very fast, and I needed a bit of time to stop this process. So we have pressure increase for adiabatic process when we pressurize air. Volume suddenly decreases, which we expected because we're pressurizing. And finally, for temperature also increased. By drawing ln of P for y-axis and ln V or volume for x-axis, we can see we draw this line with a few data here, and software automatically generated linear feed for us, and the slope of that line, this blue line, is going to be our gamma, which is here, as you can see, it is 1.59. Usually for air, isentropic exponent is 1.4. Here we are 0.2 above that number we expected, but this is an experiment and there are many contributing factors which can affect this. So we have this. As you can see, the number of data we have is not that much. There we have just a few data. If you want to increase the number of data, you need to increase the frequency here. Currently it's 20 Hertz. I'm going to increase to 1 kilohertz and repeat the experiment and see how many data I'm going to generate. Okay, class. I increase this frequency to 1 kilohertz. Now you can see the number of data. These dots are very close to each other and we have much more accurate data. I'm not suggesting to increase the frequency more than that because the number of data, when it increases, it is going to generate some delay for us, and connection between interface and computer is going to be slower, which is not going to be useful for us. So 1 kilohertz would be enough. And again, you can read the value of isentropic exponent from this final graph. After finishing and finding these graphs, you need to go to File, Export Data, and save it on the desktop in the folder of your group. So create a folder and save it as a CSV file. Later you can open that CSV file in Excel and do all calculation, all the necessary calculation you want to have. So let me select CSV file inside our group folder, and I'm calling this experiment number 1 and save it. So first experiment finished. You are going to repeat this experiment 10 times. So for the next one, you need to delete the last run data. So you click over this, and now you have clean sheet, and you can repeat the experiment and have the data and repeat all the parts. Be careful, because this is experiment. You need to include all the steps of this experiment, including the screenshot of assigning sensors, inputting calibration formulas, and any necessary step we had. You need to create a screenshot and use it.